Okay, Assalamualaikum warahmatullahi wabarakatuh. So today we will be presenting the group project for MAT 565 by the AAA team. Okay, this is our members of our team, which consists of 3 people. The first one, which is myself, Muhammad Aiman bin Sulaiman. The second one is Helmi Husaini bin Hasrul, and the third one is Aiman Nur Rashid bin Shamsul Hasni.
Assalamualaikum, my name is Hilmi Husaini bin Hasrul. I will now explain about background of this project. The Fourier series is a powerful mathematical tools that used to represent periodic function as a sum of sinusoidal functions. It was introduced by the French mathematician Joseph Fourier in the early 19th century and has become fundamental in various areas of mathematics, physics, and engineering. The basic idea behind the Fourier series is to express a periodic function as an infinite sum of sine and cosine functions. This representation allows us to analyze and understand complex periodic phenomena by breaking them down into simpler sinusoidal components. Next, a periodic function denoted as ft with period time t can be expressed as this formula.
Okay, my name is Aiman Rashid. Now I will explain about the task. So the task 1 is sketch and determine the Fourier series for even, odd and neither even nor odd function. Task 2 will be Fourier series, cosine series and sine series. And task 3 is harmonic series. So our project goal is by sketching and identifying period, about question 1. We will provide a clear and accurate sketch of the given function, highlighting key points, identify the period of the function. And number 2 is Fourier series expansion and third harmonic. Our goal is express the function as a Fourier series determining coefficients and providing the expansions. Additionally, find the Fourier series expansion up to the third harmonic, discussion, implication, or truncation.
So for task 1, I need to sketch the function and determine the Fourier series of fx for even function, odd function, and neither even nor odd function. So step 1, I find the function, which is this function I found. Then I sketch the graph of the function. Then the graph is an even function because the graph is symmetric with respect to the y-axis. Next, step 2, I determine the Fourier series of the function. So when the function is even, so the Bn is equals to 0. Then I only have to find the A0 and An. After I find the A0 and An, I just substitute the coefficient into the Fourier series formula. Next is odd function. First, I sketch the graph using the function which is fx equals to x to the power of 3. So I sketch the graph first. Then this is an odd function because the graph is symmetric with respect to the origin. Step 2, for an odd function, the A0 and An is equals to 0, so I just have to find Bn. So in this calculation, I have already found the Bn. Then I only substitute the coefficient into Fourier series formula. So next, for neither even nor odd function, so this is the graph that I have sketched. We can know that this is neither even nor odd function by seeing the graph, which is the graph is not symmetric with respect to the y-axis or the origin. So this is a neither even nor odd function. Next, step 2, I determine the Fourier series by calculate the Fourier coefficient an, a0, and bn. So I find a0 first, which is, then I find the an and then the bn. So after I find all of the coefficients, I substitute the coefficients into the Fourier series formula.
Okay, hi, my name is Ayman Nurashin. So now I will explain and present about Fourier series. Sorry, and this is task 2. So my question is, find any function fx, expand the function by sketching and give the expansion Fourier series in cosine series, sine series, and Fourier series. So to understanding is, we must choose any function, and then we must sketch graph and use Fourier series to express it and determine a cosine, sine, or neither. Okay, next. So this is my function that I use. Okay, now is cosine series formula. So in the left is formula for cosines, and the explanation is cosine series is a mathematical tool used to represent a periodic function as a sum of cosine function. A naught is the average value of the function over one period, and an represents the amplitude of the cosine term with frequency n and over L. Next is my result for cosine series from my function that I use, and the left is my calculation, and the right is my graph for cosines. Now is sine series formula. Sine series formula is represent a function infinite sum of sine function with different frequencies. Each sine term increase with n, capturing higher frequency components of the function. The sine series simplifies complex functions by expressing them as a sum of sine functions with different amplitudes and frequencies. Following equation is to find coefficients an and bn, so it can be explained using the sine series. So next is my result sine series. On the left is my calculation, and at the right is graph for the sines. Sorry. Now is Fourier series formula. So as you can see, Fourier series formula has three different formula: a0, an, and bn. So my explanation is, Fourier series represent a periodic function as the sum of sine and cosine function. A0 is the average value of the function over one period, and an and bn coefficient representing the amplitude and phase of the sine and cosine terms. The Fourier series decomposes a periodic function into a sum of sine and cosine function, providing a powerful tool for analyzing and approximating periodic signal. So this is my result Fourier series from function I use, and on the left side is my Fourier series. I combine all the equation all the formula just now, and on the right is my graph for Fourier series.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, so now I will explain to you how to do the third task or the assignment. Okay, so for this one, the question has given us the summation of y cos x and y sin 2x. Okay, the question asks to find until the second harmonic, but we need to find until the third harmonic. It's just easy, as we just need to do a few extra steps. Okay, so the first step, we need to find all the components in the table until the third iteration, as you can see here, except the ones that are given. And we need to find the summation of all the components. Okay, the second step is that we just need to find A naught and C naught. It's just easy because we just need to follow the formula and use the summation that you have counted. Okay, so the third step is to find AN, BN, and CN until the third iteration using the formula. Okay, so first we need to find A1, B1, C1, A2, B2, C2, A3, B3, and C3. Okay, so as you can see, A1 you need to find using y cos x, B1 using y sin x, and then C1 you need to insert both of them. Okay, like this. And the same for finding A2, B2, C2, and A3, B3, C3. You see? Okay. And the third step is to find alpha 1, 2, and 3 using the formula given. Okay. But after you have found the answer, you cannot just straight away use it, as we need to use a triangle method to find the actual angle. So, for example here, in alpha 3, I have written here O and A because SOHCAHTOA. Okay, so the O means opposite and A means adjacent. Okay, so the opposite here is a negative. So negative opposite will sit on the bottom right of the graph, and the positive adjacent will be on the right side of the graph, and so the triangle will be here. Okay, so we need to imagine like a circle here, and we need to take apart the angle here. So 360 we need to subtract with the angle that we have found just now, and the subtraction will be the answer. Okay, and for the last step, we just need to input the information into the general formula until the third iteration. So don't forget to put the dot here, as I have already forgotten. So until that, all the information have been put into the general formula. So we have already finished our task. It's that simple and easy. Okay, thank you for watching, and I hope you have a nice day.